Hi, Randy, K7AGE. I was looking in my February QST in the hints and kinks section on page 71. Richard, KB3 Victor Zulu Lima, wrote a little article about building a field strength meter inside of a digital voltmeter. I thought that would make an interesting project for us. So what is a field strength meter? Well, it's a meter to measure the field, your RF field, coming off your antenna. Now this is not a calibrated piece of test gear. It's not going to tell you watts or volts per meter or anything like that, but it will give you a voltage number that's just relative. So if you're doing some testing between antennas, you could say you have a quarter wave antenna and get a reading, then maybe switch to your beam or your dipole and get a reading with that, and now you'll be able to see if one is better than the other. It's just a handy thing to have around to sense the amount of RF that's being radiated. So we're going to build this field strength meter inside this digital voltmeter. And what's kind of handy about these are the ones that Harbor Freight sells. I think they're like $15. If you buy it at list price, I think it goes on sale for $4 or $5. And if you have the right coupons, you can get these for free. Sometimes you have to purchase something to get them. Sometimes if you get the right coupon, you can get a free digital voltmeter without even purchasing anything. So this is what we're going to use, and this is what Richard used in his article. So here's the article from the February QST, page 71. Let's take a closer look at the schematic. So here's the schematic. We're going to have a little antenna that we're going to mount on the top of the meter. It feeds through a 0.05 microfarad capacitor to a pair of germanium 1N34 diodes. These need to be germanium, not silicon, so the meter is more sensitive. A 470 puff capacitor to ground, then a 50K pot that we're going to use to be able to adjust the value out of here, although with the digital voltmeter you probably just leave it all the way up, with a 0.01 microfarad capacitor to ground. The switch is here for safety so that when using the meter for normal voltage measurements you don't have any voltage up on the antenna. So here's a picture of how Richard used a little piece of perf board, and it fits in the meter here up above the circuit board, and you place all the parts on there. Here he's mounted a little jack for the antenna and the switch out the side. We're going to do the same thing. Here's the freebie Harbor Freight meter, and let's take a look at the inside. The back is held on with two screws. You can pop those off, then the back comes right off. So here's the meter. You got the battery, the circuit board, and here's the display, and there's a lot of room behind the display here. So what I have is a piece of perf board that I'm going to use to go in the meter, and this is what the full size of the board started out to be. And I just kind of, it's really hard to see, but I kind of laid out where the parts are going to go on the board so that I've cut the board down to this size, and this was what will fit inside the meter here to hold everything. And I'm going to use a new soldering iron for this project. This is an isol tip soldering iron. What's kind of nice about this is that it's a battery powered soldering iron, and it just drops in the charger here when you're not using it to charge up. And it comes with a couple different tips. It takes a few seconds for it to warm up, but I thought this would be an interesting project to try out the new isol tip, and this is a model 7700. So we'll give this a try. No wires, a wireless soldering iron. So I'm going to start mounting some of the parts on the board here. So here's my little board. Here's the first capacitor. This is the 0.05. That's going to be used for the antenna. I'm just going to poke that in here in the end, like that. And just kind of bend the leads over a little bit. In fact, I'm going to bend them over flat here to the board. This will keep the parts from falling out, and that's how I'm going to solder. So I'm going to place the first diode. This diode is going to go next to the capacitor here, and this is one end is going to be at the junction of the opposite end from where the antenna gets connected. So there, I place that on the board. Okay, the second diode is going to mount across the bottom edge of the board here. So I want the anode end going to be common with the other diode. So it's going to put it in these holes right here. So here's the bottom side of the board, and what I kind of do is bend the leads over so they kind of touch each other, because that's going to be the junction where I solder. Next, I'm going to mount the position the 470 puff capacitor at the end of the diode, and it's going to go here. Basically, I'm going to run the ground across the this top edge of the board here. So there's the 470 puff. I'm just going to turn this over and bend the leads here a little bit. Next, I have a little trim pot, a 50K pot. I'm going to mount that in here, get the leads positioned the way I want them, and just going to put that in a series of 3 holes. So there's the pot, and I'm just going to bend the leads over here for now to keep it from falling out. And the next thing is to mount the 0.01 capacitor, and it's going to go next to the pot here. And put it in there and turn it over and bend the leads. So there's basically all the parts on the board. All that's left to do is basically solder them together. This is a view of the bottom of the board. You can see I have the leads all bent over, grouping together for the various junctions. So here's one. Here's a long lead from one of the capacitors, which will be my ground bus, and there's a couple other junctions there. So we'll get out the ISO tip and some solder. And this has a light on it, which is handy too. So I'm going to heat this up. A little solder on the iron. And I'm just going to kind of put it on all 3 leads there and feed it some solder. And there, they nice and silver across all of those. Here's another junction here. Reposition this a little bit. And they're kind of loose. This isn't the greatest technique in the world. Okay, there's a group of solder on those. Let's get, I got too much solder here. Bang it off in the wastebasket, fling off the excess solder. There's a button, heat it up. I got these 2 here. There we go. Feed it some solder, got it. And now, got a couple little junctions here. I got that one. Put some solder. And get in here and solder those 2 wires together. And when you're done, just drop the iron back in the charger. I think that all looks good. I can kind of pick away here. I don't see any wires separating from the solder. And I think I've got the board built. Okay, so here's the back of here's the meter where it's going to go. And I'm going to take some of these caps that are sticking up high and just bend them over real gently. I don't want to break the lead going into the capacitor. Here we go. Get the profile down. Now this is going to mount in here like this. It's going to sit in there like that. This is the junction here with the capacitor where the antenna is going to go. So I'm going to use an RCA jack up in the top for the antenna, and I have a toggle switch that I can fit over here on the end. So I got lots of room. Okay, I basically got a little couple marks on here where I'm going to put the antenna jack. Here's a little trick. I'm going to use the iron here and heat that up. I'm just going to touch that right at that crosshair and melt a little hole. Here we go. And that'll be for my drill. Alright, I got the switch mounted and the RCA jack, and so the board will go in there like that. So I have a little bit of wiring to do. I have to wire from the antenna jack to the end of the capacitor, the output through the switch, and from the other side of the switch to the plus terminal where the test lead goes in, and then the ground common bus, another wire will come down to the ground terminal where the leads go in. So I'm going to go ahead and do that wiring now. Okay, so now I have all the wires to the board. I have a red wire going up to the RCA, the brown black wire is to the ground terminal, and the blue goes through the switch and to the positive terminal. So that should just about do. The other thing I've done is taken about a 19-inch piece of some heavy wire that I had and soldered it into an RCA plug to use for my antenna. Okay, I have the meter all put together. I have the switch up to use the 19-inch whip. I have it on the 20 volts DC scale. I have my ICOM V80 HT. I can use as a RF source here. I'm going to hold it about 2 feet away on low power, K7AGE. There it is, 0.4 volts. I'm going to take it to medium power, 1.3, so from 0.4 to 1.3. That's a relative increase. And let's go to high power, K7AGE, about 2.2, you can see it kind of varies as I move around. So the meter does show you the difference in the field intensity as I change power on the meter. And again, thanks to Richard, KB3VZL, for sending in this article to be published in the February 2015 QST. Just a handful of parts, not much to it. Again, germanium diodes to make it more sensitive. Get your meter at Harbor Freight. If you got the right coupons, you can get it for free. You can follow me on Twitter at K7AGE. Follow me on Google Plus at +K7AGE. And don't forget to subscribe to my YouTube videos so you can stay up to date with everything. 73's K7AGE, Randy.